The TRIZ 40 Inventive Principles. Genrich Altshuller, creator of the theory of inventive problem-solving, better known by its Russian acronym TRIZ, analyzed thousands of patents and identified a group of 40 techniques that inventors used successfully to solve problems across different fields. To inspire new inventors in their problem-solving, I created this video illustrating one of these principles. Principle 18. Mechanical vibration. Cause an object to oscillate or vibrate. For example, oscillating multi-tool. Oscillating tools generate tens of thousands of oscillations per minute and are ideal to make accurate cuts in small spaces with less dust. Increase its frequency, even up to the ultrasonic. For example, ultrasonic metal welding. This process can weld dissimilar metals without flux or solder.
Ultrasonic metal welding can be used to efficiently join similar or dissimilar material combinations. Because this is a solid-state process, materials only reach 1/2 to 1/3 of their melting point. This avoids issues associated with a mismatched coefficient of thermal expansion between two dissimilar materials, which leads to joint failures. Ultrasonic metal welding can be used with copper, aluminum, nickel, and magnesium, and cycle times are typically less than a half second. This process works well with materials that have high thermal conductivity, for the multi-layer thin foil welds common in battery applications, for structural aluminum joints, and for consumer electronics and medical devices. Here we see a multi-layer foil-to-tab joint typical of internal battery cell connections with a cross-section of that same joint. This cross-section shows an aluminum-to-copper weld for a battery tab application with tooling impressions that are typical of the process.
Use an object's resonant frequency. For example, resonant pavement breakers. The controls of this machine can continuously adjust the resonant beam frequency and match it to the pavement.
Throughout the world, roadways are an integral part of the transportation infrastructure that contribute to the productivity and economic growth of a region. And while their value can be immeasurable, communities still face a cost-benefit analysis when evaluating road rehabilitation options. Traditional road rehabilitation is expensive, time-consuming, and very disruptive to its surroundings and community. Quosco's resonant rubblization process is the proven alternative to traditional construction methods. A rubbleized road with a hot mix asphalt overlay can extend the life of a concrete roadway by over 20 years and do so in a quick, cost-effective, and environmentally friendly manner with minimal disruption to its surroundings. It is approximately 5 times faster than traditional tear-out and replace methods and runs about 1/2 the cost. And because the existing concrete roadway is recycled in place, there is minimal impact on the environment. The key to Quosco's resonant rubbleizing process lies in its innovative vibration technology. Shown here in slow motion, the weighted resonant beam strikes the concrete 44 times per second at an amplitude of less than 2 centimeters. This low-impact process minimizes disruption to the surrounding environment and does not damage underground utilities while leaving the existing subbase completely intact. Plus, the Quosco rubbleizer fractures the concrete at a 40-degree angle, which creates an interlocking base material that maintains 90% of the strength of unbroken concrete and eliminates reflective cracking. Once rubblized, 1 or 2 passes over the fractured concrete with a standard vibratory roller is all that is needed to compact the new interlock base material. From here, the hot mix asphalt can be applied. No bonding agent is required. The process is so quick that one machine can rehabilitate 1 kilometer of a 2-lane road per day. With over 5 million square meters of concrete pavement rehabilitated, Quasco's Resonant rubblization process has proven to be the superior alternative to traditional roadway reconstruction.
Use piezoelectric vibrators instead of mechanical ones. For example, piezo-based pump. A piezo-based pump has high power density with only one moving part.
Kinetic Ceramics is revolutionizing fluid movement with a solid-state pump that has the highest power density in its class and only one moving part. Our compact pump systems, which can be customized to meet challenging conditions, have greater than 40% energy efficiency. The self-priming pump can operate remotely and be directly submerged in fluids. This resilient system can also pump highly viscous fluids and function in corrosive environments with little to no impact on performance. As we explore our components, you'll see the elegance of our engineering design. Our solid-state actuator has no bearings to lubricate and no dynamic seals that may leak. These simplified mechanics deliver maximum reliability and provide the ability to operate in extreme environments, ranging from cryogenic temperatures to 200 degrees Celsius. As we look closer, the driving force behind our solid-state pump is our proprietary piezo motor, which is comprised of a stack of piezoelectric discs. In this pump, the piezo motor is immersed in fluid and can deliver pressures up to 10,000 pounds per square inch. This rapid, powerful oscillation forces fluid through the outlet valve. Our drivers provide instantaneous control of the frequency and duty cycle, adjusting pressure and flow rate with extreme precision at speeds of up to 1/2000th of a second. Our compact, powerful, solid-state pump systems are already helping engineers innovate in oil and gas, aerospace, medical, transportation, and the industrial industries. We're ready to reimagine solutions for your industry too.
Use combined ultrasonic and electromagnetic field oscillations. For example, electromagnetic acoustic transducers. Electromagnetic acoustic transducers have many applications including pipe inspection and flow measurement. Share this video and add your examples of this inventive principle in the comments below. Mechanical vibration. Cause an object to oscillate or vibrate. Increase its frequency, even up to the ultrasonic. Use an object's resonant frequency. Use piezoelectric vibrators instead of mechanical ones. Use combined ultrasonic and electromagnetic field oscillations.